Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, motion in a plane, chapter 4, ncert solution, part 3. Our mission is to provide free classes on YouTube for all students of class 6 to class 12 and the students who are preparing for IIT JEE, NET, NDA and other competitive examinations. Before we begin, we request you to subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Let us begin the lesson. In the last session we have done till sum number 4.21. In today's session we'll start with 4.21. In the last session we have done sum number 4.20. In today's session we'll start with 4.21. A particle starts from the origin at t is equal to 0 second with a velocity of 10.0 j meter per second and moves in xy plane with a constant acceleration of 8.0 I plus 2.0 j meter per second square. A. At what time is the x coordinate of the particle 16 meter? What is the y coordinate of the particle at that time? B. What is the speed of the particle at that time? The solution for 4.21 is A. Velocity of the particle is 10 j meter per second. Acceleration of the particle is 8 I plus 2 j meter per second square. Also, A acceleration A is equal to dv by dt, that is 8 I plus 2 j. dv is equal to 8 I plus 2 j multiplied by dt. Integrating both the side, vt is equal to 8t I plus 2tj plus u, where u is equal to velocity vector of the particle at t is equal to 0, v is equal to velocity vector of the particle at time t, but v is equal to dr by dt. dr is equal to v dt, that is equal to 8ti plus 2tj plus u dt. Integrating the equation with the condition at t is equal to 0, r is equal to 0 and at t is equal to 1, r is equal to r, we get r is equal to ut plus half at square j plus half 2 multiplied by t square j, which gives ut plus 4t square I plus t square j is equal to 10 j t plus 4 t square I plus t square j. xi plus yj is equal to 4 t square I plus 10t plus t square j. Since the motion of the particle is conformed to the xy plane, on equating the coefficient of I and j, we get x is equal to 4t square, t is equal to x by 4 to the power half, and y is equal to 10t plus t square, where x is equal to 16 meter, t is equal to 16 upon 4 whole square is equal to 2 seconds. Therefore, y is equal to 10 into 2 plus 2 square is equal to 24 meter. B. Velocity of the particle is given by Vt is equal to 8ti plus 2tj plus u. At t is equal to 2 seconds, Vt is equal to 8 into 2i plus 2 into 2j plus 10j, which is equal to 16i plus 14j. Therefore, speed of the particle modulus of v is equal to 16 square plus 14 square, that is under root of 256 plus 196 gives under root of 452, which is equal to 21.26 meter per second. Now let us do 4.22. I and j are unit vector along x and y axis respectively. What is the magnitude and direction of the vector I plus j and I minus j? What are the components of a vector a is equal to 2i plus 3j along the direction of I plus j and I minus j? So the solution for 4.22 is, consider a vector p given as p is equal to I plus j. Pxi plus pyj is equal to I plus j. On comparing the components both on both sides, we get px is equal to py is equal to 1. Modulus of px is equal to under root px square plus py square is equal to 1 square plus 1 square, that is root 2, equation 1. Hence the magnitude of the vector I plus j is root 2. And let theta be the angle made by the vector p with the x-axis as shown below. Tan theta is equal to py by px. Theta is equal to tan inverse 1 by 1, that is 45 degree. Equation number 2. Hence the vector I plus j makes an angle of 45 degree with x-axis. Let q is equal to I minus j. Qx I minus qyj is equal to I minus j. Qx is equal to qy is equal to 1. Now modulus of q is equal to under root qx square plus qy square is equal to root 2. This is equation number 3. Hence the magnitude of the vector I minus j is root 2. And let theta be the angle by the vector q with the x-axis, and as shown in the figure below. Tan theta is equal to qy upon qx. Theta is equal to minus tan inverse 1 upon 1, that is minus 45 degree, which is equal to minus 45 degree. This is equation number 4. Hence the vector I minus j makes an angle of minus 45 degree with the x-axis. It gives that a is equal to 2i plus 3j, axi plus ayj is equal to 2i plus 3j. On comparing the coefficient of I and j, we have ax is equal to 2 and ay is equal to 3. Modulus of a is equal to under root 2 square plus 3 square, that is root 13. Let ax mix an angle theta with x-axis as shown below. Tan theta is equal to ay upon ax. Tan theta is equal to tan inverse 3 by 2. Tan inverse 1.5 is equal to 56.31. Angle between the vector 2i plus 3j and I plus j and I plus j, theta is equal to 56.31 minus 45, which is 11.31 degree. Components of vector a along the direction of p making an angle theta is equal to a cos theta p, that is equal to a cos 11.31 I plus j upon root 2, which is equal to root 13 9.9806 upon root 2 I plus j, that is equal to 22.5 I plus j, which is equal to 25 upon 10 root 2 is equal to 5 upon root 2, that this is equation number 5. Let theta double dash be the angle between the vector 2i plus 3j and I minus j. The theta double dash is equal to 45 plus 56.31 is equal to 101.31 is equal to a cos theta double dash q is equal to a cos theta double dash I minus j upon root 2. Now the next line is root 13 cos 101.31 I minus j root 2 is equal to root 13 upon 2 sine 11.30 I minus j is equal to minus 2.550 into 0.1961 I minus j is equal to minus 0.05 I minus j, which is equal to minus 5 upon 10 into root 2, which is again equal to minus 1 upon root 2, that is equation number 6, and this is the answer. Now let us do the next question, 4.23. For any arbitrary motion in space, which of the following relations are true? A. V average is equal to half V T1 plus V T2. B. V average is equal to R T2 minus R T1 upon T2 minus T1. C. Vt is equal to V0 plus AT. D. RT is equal to R0 plus V0 T plus half AT square. E. A average is equal to VT2 minus VT1 upon T2 minus T1. The average stands for average of the quantity over the time interval T1 and 2T2. So the solution will be A, false. It is given that the motion of a particle is arbitrary, therefore the average velocity of the particle cannot be given by the equation. B, true. The arbitrary motion of the particle can be represented by this equation. C, false. The motion of the particle is arbitrary. The acceleration of the particle may also be non-uniform. Hence, this equation cannot represent the motion of the particle in space. D, false. The motion of the particle is arbitrary. Acceleration of the particle may also be non-uniform, may be new or non-uniform. Hence, the equation cannot be represented by the motion of the particle in space. E, true. The arbitrary motion of the particle can be represented by this equation. Now let us move to the next question, that is problem 4.24. Read each statement below carefully and state with reason an example if it is true or false. A scalar quantity is one that A is conserved in a process, B can never take negative value, C must be dimensionless, D does not vary from one point to another in space, E has same value for observer with different orientation of axis. So solution of 2.24a false. Despite being a scalar quantity, energy is not conserved in inelastic collision. B false. Despite being a scalar quantity, temperature can take negative values. C false. Total path length is a scalar quantity, yet it has the dimension of length. D false. A scalar quantity such as gravitational potential can vary from one point to another in space. E true. The value of a scalar does not vary from observer with different orientation of axis. Let us move on the next question, that is 4.25. An aircraft is flying at a height of 3400 meter above the ground. If the angle suspended at a ground observation point by the aircraft position 10 seconds apart is 30 degrees, what is the speed of the aircraft? The position of the observer and the aircraft are shown below. Height of the aircraft from the ground OR is equal to 3400 meter. Angle subtended between the position angle POQ is equal to 30 degree. Time is equal to 10 seconds. In triangle PRD 10-15 degree is equal to PR upon OR. PR is equal to OR 10-15 degree is equal to 3400 into 10-15 degree. Triangle PRO is similar to triangle RQO is equal, therefore PR is equal to RQ is equal to PQ, therefore PQ is equal to PR plus RQ, which is equal to 2PR. This is and putting the value of R, we get 2 into 34 10-15 degree, and putting the calculating it, we get 6800 into 0.268, which is equal to 1822.4. Speed of the aircraft is equal to 1822.4 upon 10, which is equal to 182.24 meter per second. Now let us do the next sum, which is 4.26. A vector has magnitude and direction. Does it have a location in space? Can it vary with time? Will two equal vector A and B at different location in space necessarily have identical physical effects? Give examples in support of your answer. Solution of 4.26. A vector has no definite location in space. This is because the vector remains invariant when displayed in such a way that its magnitude and direction remains the same. However, a position vector has a definite location in space. A vector can vary with time. For example, the displacement vector of a particle moving with a certain velocity varies with time. A equal vector located at different location in space need not produce the same physical effect. For example, two equal force acting on an object at different points can cause the body to rotate, but their combination cannot produce an equal turning effect. Now let us do the next problem, that is 4.27. A vector has both magnitude and direction. Does it mean that anything that has magnitude and direction is necessarily a vector? The rotation of the body can be specified by direction of the axis rotating and the angle of rotation about the axis. Does that make any rotation a vector? A physical quantity having both magnitude and direction need not be considered a vector. For example, despite having magnitude and direction, current is a scalar quantity. The essential requirement for a physical quantity to be considered a vector is that it should follow the vector law of addition. The rotation of a body about an axis is not a vector quantity as it does not follow the law of vector addition. However, a rotation by a certain small angle follows the law of vector addition and therefore considered a vector. Now let us move to the next problem, that is problem number 28, 4.28. Can you associate vector with A, the length of a wire bent into a loop, B, a plane area, C, a sphere? Explain. One cannot associate a vector with the length of a wire bent into a loop. One can associate a area vector with a plane area. The direction of this area of this vector is normal inward or outward to the plane area. One can not associate a vector with the volume of the sphere. However, an area can be associated with the area of a sphere. Now let us do the next question, that is 4.29. A bullet fired at an angle of 30 degree with the horizontal hits the ground 6 kilometer away. By adjusting the angle of projection, can one hope to hit a target 5 kilometer away? Assume the muzzle Adjusting the angle of projection, can one hope to hit the target of 5 km away, assuming the muzzle speed is fixed and neglect the air resistance? No. Range is equal to range R is equal to 3 km. Angle of projection theta is equal to 30 degree. Acceleration due to gravity g is equal to 9.8 meter per second square. Horizontal range of the projection velocity u square is given by the relation r u naught square sine 2 theta upon z. Putting the value of r and theta, we get 3 is equal to u square sine 2 theta sine 60. uh, 3 is equal to u square u naught square upon g sine 60 degree. U square upon u naught square upon g is equal to 2 root 3. The maximum range R max is achieved by the bullet when it is fixed at an angle of 45 degree with the horizontal, that is R max is equal to u naught square upon g. On comparing equation 1 and 2, we get R max is equal to 3 root 3 is equal to 3 into 1.732 is equal to 3.46 kilometer. Hence, the bullet will not hit a target 5 kilometer away. Now, let us move to the next question, that is question number 30, 4.30. A fighter plane flying horizontal at at an altitude of 1.5 km and speed 720 km per hour passes directly overhead an anti-aircraft gun. At what angle from the vertical should the gun be fired for the cell with muzzle speed 600 meter per second? What angle from the vertical should the gun be fired for the cell with muzzle speed 600 meter per second hit the plane? At what minimum altitude of the pilot fly the plane to avoid being hit? Take z is equal to 10 meter per second square. So height of the fighter plane is equal to 1.5 kilometer, that is 1500 meter. Speed of the fighter plane v is equal to 720 kilometer per hour, which is equal to 200 meter per second. Let theta be the angle with vertical so that the cell hits the plane. The situation is shown in the figure below. Muzzle velocity of the gun is equal to u is equal to 600 meter per second. So let theta be the angle of the with the vertical so that the cell hits the plane. The situation is shown in the figure below. Muzzle's velocity of the gun is equal to u is equal to 600 meter per second. Time taken by the cell to hit the plane is equal to t. Horizontal distance traveled by cell is equal to ux into t. Distance traveled by the plane is equal to vt. The cell hits the plane, hence these two distances must be equal. Uxt is equal to vt. U sine theta is equal to v. Sine theta is equal to v upon mu is equal to v upon u, which is equal to 200 upon 600, which is equal to 1 by 3 is equal to 0.33. Theta is equal to sine inverse 0.33 is equal to 19.5. Theta is equal to sine inverse 0.33 is equal to 19.5 degree. In order to avoid being hit by the cell, h is equal to u square sine square 90 minus theta upon 2g is equal to 600 into 600 theta, theta square uh, cos square theta upon 2g, which is equal to 360000 into cos square 19.5 upon 2 into 10 is equal to, so h is equal to u square sine square theta and sine square 90 minus theta upon 2g. 600 square is equal to cos square uh, theta upon 2g. Putting the values 636000 into cos square 19.5 upon 2 into 10, which is equal to 18. So 360000 into cos square 19.5 upon 2 into 10 is equal to 18,000 into 0.943 square, which is equal to 16,006.482 meter, which is approximately equal to 16 kilometer. Now let us do the next question, that is 4.31. A cyclist is riding with a speed of 27 km per hour. As he approaches a circular turn on the road of radius 80 meter, he applies brakes and so he applies brakes and reduces his speed at a constant rate of 0.5 meter per second every second. What is the magnitude and direction of the net acceleration of the cyclist on the circular turn? Speed of the cyclist v is equal to 27 km per hour, 7.5 meter per second. Radius of the circular turn is equal to r is equal to 80 meter. Centimeter force is given as AC is equal to V square upon R, that is 7.5 whole square upon 80 is equal to zero point 0.7 meter per second square. Now, the situation is shown in the given figure. Suppose the cyclist begins cycling from point P and moves towards point Q. At point Q, he applies the brake and acceleration. Brakes and deaccelerate the speed of the object by 0.5 meter per second square. The acceleration is along the tangent at q and opposite to the direction of rotation of the cyclist. Since the angle between AC and AR is 90 degree, the solution so the acceleration is along the tangent at q and opposite to the direction of the motion of the cyclist. Since the angle between AC and AR is equal to 90 degree, the resultant acceleration A is given by, that is A is equal to under root AC square plus AY square, AT square. Put, putting the value of AC and AT, we get zero point 0.7 whole square plus zero point 0.5 whole square is equal to under root 0.74, that is 0.86 meter per second, where theta is the angle. Okay, tan theta is equal to AC by 80, where theta is the angle of the results. So where theta is the angle of the resultant with the direction of the velocity. Tan theta is equal to zero point 0.7 upon zero point 0.5, which is equal to 1.4. Therefore, theta is equal to tan inverse 1.4 is equal to 54.46 degree. Time taken by the projectile to reach point P is equal to T. Applying the first equation of motion, changing the vertical and horizontal direction, we get Vy. The acceleration is along the tangent at Q, the opposite to the direction of motion of a cyclist, since the angle between QC and QR is 90 degree. The resultant acceleration, so we can write, since angle between AC and AR is 90 degree, the resultant acceleration A is given by A is equal to AC square plus AT square is equal to zero point 0.7 square plus zero point 0.5 square is equal to 0.74 root is equal to 0.86 meter per second square. Tan theta is equal to AC upon AT. So where theta is the angle of the resultant with the direction of velocity, tan theta is equal to zero point 0.7 upon zero point 0.5 is equal to 1.4. Theta is equal to tan inverse 1.4, that is 54.46. Now let us do question number 4.32. A. So for a projectile, the angle between the velocity and x-axis as a function of time is given by theta t is equal to tan inverse v0 y minus jt upon vax. B. Shows the projectile angle theta 0 for the projectile launched from the origin is given by theta naught is equal to tan inverse 4 hm upon r, where the symbol have their usual meaning. 4.32. Let Vox and Voy respectively be the initial components of velocity of the projectile along x plus vertical y direction. Let Vx and Vy respectively be the horizontal and the vertical component of the velocity at a point. Time taken by the projectile to reach point P is equal to t. Applying the first equation of motion along with the and vertically and applying the first equation of motion along the vertical and horizontal direction, we get Vy is equal to V naught y is equal to zt and Vx is equal to V naught x. Tan theta tan theta is equal to Vy upon Vx, which is equal to V0y up minus Gx upon Vox. Theta is equal to tan inverse V naught o y minus gt upon V naught x. Maximum vertical height hm is equal to u naught square sine square 2 theta upon 2g, equation 1. Horizontal range r is equal to u naught square sine theta upon 2g. R is equal to, so horizontal range is equal to r is equal to e square sine 2 theta upon g. This is statement 2. Solving equation 1 and 2, HMIR is equal to sine square theta upon 2 sine 2 theta. Sine square theta is equal to sine into sine. 2 sine theta is equal to 2 into sine theta into cos theta. So why? Because we know that sine 2 theta is equal to 2 sine theta into cos theta is equal to 1 by 4. So we can write sine theta into sine theta upon 2 into sine theta cos theta, which is equal to 1 upon 4 sine theta upon cos theta is equal to 1 by 4 tan theta. So next, solving this equation, we can find tan theta is equal to 4 hm upon r. Theta is equal to tan inverse 4 hm upon r. And this is the end of this chapter 4. Before we close, we request you to subscribe, like, and share our channel among your friends and relatives, and also keep ask them to click on the subscribe button to support us. Thank you very much for uh, for your support and watching our videos. Thank you.